This is Economics PowerPoint Lecture 5 on Elasticity of Demand. Let's learn some economics. We'll start here with the price elasticity of demand. Excuse me. And what we have is that this is a derivative of the law of demand. Now, what did we learn in the law of demand? We learned in the law of demand that price and quantity are negatively correlated. In other words, high prices, low demand, low prices, high demand. Well, that's all well and good, except it rather begs a question, doesn't it? It begs the question, how much? The law of demand tells us that when there's a price change, there will be a change in the demand in the quantity demanded, but it doesn't tell us how much of a change there will be in the quantity demanded. And so we can think of elasticity as answering that question. And so therefore we can think of elasticity as really a measurement of the sensitivity of the quantity demanded to a change in price. Now we'll look at three different types of elasticity. We'll look at price elasticity of demand, which is to say the sensitivity of demand based on price changes. We'll look at cross elasticity, which is the sensitivity in the quantity demanded of one product based on a price change in a related product. One of the things we learned as a determinant of demand when we were talking about shifting the demand curve, one of the things we learned was that, well, if two products are related, a price change in one of them is going to affect the demand for the other one. And we had substitutes and complements, and we'll deal with that. And then we also learned there in our discussion of shifting, and I think that was from Lecture 3, that if there is a change in income, there will be a change in quantity demanded. And so we'll also learn about income elasticity of demand. We'll start here with price elasticity of demand. And you see how the coefficient is going to be derived. We may as well get comfortable with this because we're going to look at it over and over and over. It's the percentage change in the quantity demanded over the percentage change in price. Now let's look at this. First, we say that a product's inelastic if this coefficient, which is the price elasticity of demand, is less than 1. Well, if it's less than 1, let's just look at the math here for just a second. Let's just look at the basic elementary conclusion that we draw from this. What this means is that the percentage change in quantity will be less than the percentage change in price, right? If the numerator is less than the denominator, you're going to have a number that's less than 1. Whereas if the numerator, in this case the quantity demanded, is greater than the denominator, which is the change in price, percentage change in price, you're going to have a number that's greater than 1. And so we'll call it elastic, which means that if it's greater than 1, it's a greater sensitivity of demand. Demand is more sensitive to a price change than if it's less than 1. Okay? And notice another thing here, and we'll deal with this a little bit more in terms of just the basic relationship based on this coefficient. Note a couple of things. Okay? Our interest here is in the ratio of the percentage change in quantity to the percentage change in price. And so we're going to be looking largely at the number 1. Okay? And we're going to deal with this at length, but I may as well introduce it now. What would it mean if that number were close to 0 or were 0 itself? Okay? Well, if it was 0 itself, what would that mean? The only way this number could be 0 is if the percentage change in quantity was 0. Well, we know from the law of demand that can't really happen, because what the law of demand tells us is that if there's a change in price, there's going to be a change in the amount demanded. Okay, higher price is less demanded, lower price is more demanded, but it means that if there's a change in price, it means that there has to be a change in the quantity demanded. Now, what we know then is that this number is not going to be 0. It could be very, very close to 0. What would it mean if it's very, very close to 0? Well, if it's very, very close to 0, it means that demand for the product is very insensitive to a price change. Okay, and we'll look at what causes this. Whereas if this number were very, very large, again, we can't move this number to infinity, but if this number were very, very large, it means that you have a product where the demand for it is very, very sensitive to a price change. Okay? we just want to make a few general statements about elasticity, a couple of notes before we move any further. The first is that what we're going to notice is that elasticity is not uniform throughout a demand curve or a demand line. What's going to happen is a demand curve becomes progressively more elastic at higher prices. Okay, which is to say, now we want to remember, always keep in the back of your mind what we mean by elasticity. Elasticity is the sensitivity of demand, the quantity demanded, based on a price change. Okay, so it's going to become progressively more elastic, progressively more sensitive at higher prices. Ultimately, the reason for this is because at a higher price, it's a greater percentage of your income. One of the things we're going to find out towards the end of this lecture is that one of the determinants of the elasticity of a product, or the sensitivity of demand for a price change in a product, is going to be the percentage of income that product is. The higher the price, the greater the percentage of income, and so the more elastic it becomes. Okay. The second thing we want to note is that, at least as far as price elasticity is concerned, we're not concerned with whether it's greater than or equal to zero, greater than or less than zero. Okay. We're interested only in the magnitude. We're actually more interested in the number 1 than we are in the number 0 when it comes to price elasticity. And so what we're going to end up using, we're going to use absolute value when we deal with price elasticity. Now, when we move on to cross elasticity and to income elasticity, we're going to bring the sign back in. We're going to be, once again, concerned with whether it's greater than or less than 0. But for price elasticity, we won't worry about that. Now, the final note is what we're going to deal with directly, okay? Because there's a problem in the way the math is worked with the calculation of the elasticity coefficient. And you look at this: a price increase from $2 to $4 is a 100% price increase. Difference of $2 divided by the base, 100%. But the same change in price of $2 is only going to be a 50% price decrease if we start out at 4. Well, we don't want that. The percentage change should be the same. It shouldn't matter whether we're going to go up or down the demand line. It should be the same elasticity. How we're going to ultimately deal with that is by taking the average of those two prices, which is going to be given to us by the midpoint. Now, as we were just talking about, okay, the average of two quantities and two prices resolves this dilemma. We take two quantities, take quantity 100 and 200. Okay, if we move from 100 to 200, as we just saw with the previous slide with prices, that's a 100% change. If we move from 200 to 100, that's a 50% change. Okay, you have the same reduction, 100 units, but it matters greatly which base you're using. And so what we're going to do is we're going to standardize the base by taking the average of the two numbers. Okay, so we take, and that average is the midpoint. Okay, the midpoint on the line between the two points on the demand curve. And so what we're going to end up with is 100 minus 200 divided by 150. Okay, you see this is the midpoint. That'll give us 2/3, or approximately 0.67, 67%. Now again, remember what we're ultimately I'm gonna stress this over and over. What this number actually means is that for every 1% change that you have in price, you're going to have a 0.67% change in the quantity demanded. That's why we talk about that being inelastic. Okay, and we'll deal with that when we deal with elasticity at greater length. Now let's look at a comparison of elasticity so that we can understand what elastic versus inelastic looks like. Okay, on a demand function. And the book has some graphics for this, but the book, I prefer this one because the book breaks their graphic into 3 different images, whereas here I impose them on the same price quantity graph so that we can really get a good comparison of the two. Now let's look at this. Suppose that we have two products. One is given by demand 1, and 2 is given by demand 2. All right, we have the same price change in the product, notice. All right, well, if we change the price from $4 to $6, let's say we increase the price from $4 to $6, okay? which just from a quick glance at it means you've increased the price by 50%. The price started out at $4, you've raised it by $2 to the $6 figure, which means you've increased price by 50%. Demand is going to drop from here to here. That's not surprising. We know from the law of demand that if we raise the price of the product, that demand for the product will drop. Okay, so that's not surprising. It drops from 20 units down to 15 units. Okay, and we'll figure this out in the next slide. What this actually, how the elasticity coefficient is going to look. Well, let's look at product 2. Okay, same price change, $4 to $6, but look at the quantity demand change. Okay, the quantity demand change is going to drop from here to here. This is demand line 2. So it's going to drop from here all the way up to here. So we're going to drop this one from 80 units down to 15 units, which will be a change of 65 units. Okay, with me so far? Simple enough. We can tell from this that this line then is much more inelastic, meaning that demand is much more insensitive to a price change. Why? Same price change, much smaller drop in demand. Even as a percentage, we'll see that that's a much smaller drop in demand than it is from here. Okay? Now let's look at an example of what we've been talking about. This brings us back to the graph of the relative price elasticity of demand for two products. Okay, we have the demand for product D1, the demand for product D2. We have a price change from $4 to $6, and because we're using the midpoint, doesn't matter which way we go, up or down, it'll be the same elasticity. Okay, so as far as the percentage change in price, we see it here. The difference in price is going to be 4 to 6, which is $2 regardless. Then we use the midpoint, which we just discussed, and that will give us 2/5. Okay. Now, in terms of the quantity demand change, the quantity change along this axis, we're going to do the same thing with the midpoint. We're going to say, okay, in this first product, we go from 20 to 15 or 15 to 20. Okay, that's going to be a 5-unit change. We see that right here. Divided by the midpoint between 20 and 15 is 17.5. That'll give us 5 17.5ths, or 10/35ths, which works out to be 2/7. We look at product 2, and what we'll see is it's a much larger percent change in the quantity demanded for the same price change. We're holding the price change as a constant here, okay? So we have a much larger demand change, okay, from 80 units to 15 units, or from 15 units to 80 units, depending on which way you're going on the demand curve, okay? Well, either way, we use the midpoint here, and that's going to work out to 130/95ths, or 26/19ths. Okay, and so we look at the elasticity of the first demand line, and we have the 2/7ths, which is the change in quantity that we calculated, divided by 2/5ths, the change in price. We end up with 5/7ths. Okay, a number less than 1 is what it should be pointed out to, and so this is inelastic. Now, just from a quick glance at the graph, we can see that this line looks a lot less sensitive to a price change than does this line. So our intuition, is confirmed in this. Now, when we look at the elasticity of the second line, we get a very different number. We just calculated the percentage change in quantity to be 26/19ths. The percentage change in the price is the same as with the first line because we've held price constant. Okay, that's going to give us 130/38ths, or 65/19ths. Okay, now we're going to convert that to a decimal. You can go ahead and convert that to a decimal now. All that we're interested at this point, and the point that I'm driving at, is we can kind of see from looking at the lines that this line here, demand for product 2, is much more elastic than demand for product 1. Okay, and sure enough, the demand for product 1 has a price elasticity of demand of less than 1, 5/7ths. This one has one that is much greater than 1. In fact, if I'm doing the math correctly, it's greater than 3, and so it's a highly elastic product. Now we've worked out an example of this. You may recognize this. This is an extended form of the demand curve that we've been using actually throughout. We're going to continue using this one. One of the things I like about the way I do this, as opposed to the way textbooks do it, is I keep kind of a running example as long as possible throughout the half semester that we'll be in. Remember, this was when we originally did this demand schedule. We had $2, $4, $6, $8, and $10. Well, now we've just simply extended that, and the linear equations that we calculated in the discussion of in the introduction to demand, it's the same equation. It all comes from the same thing, okay? It's just simply drawn from it. And so we figured out the elasticity. Now, when we move from $1 to $2 and then move to $2 to $3, and either way, whether we're going up or down, it's going to be the same because we're using the midpoint. I've worked out the math here to give you an idea. We want to get some practice with this because in the problem for this week and in the problems for the final and things like that, we're going to have to get used to doing this. So this just kind of walks you through the math. It's one of the things textbooks don't do is really kind of walk you through the math. We're going to walk through the math just a little bit, and we'll only walk through the math on a couple of these because life is short and we have other fish to fry. But at any rate, okay, so our change in quantity is 30 units from 330 to 300. We take the midpoint of that line. That'll calculate for us the percentage change in quantity. We do the same thing for price. We have a change from $1 to $2, a $1 change. We divide that by the midpoint, and that's going to give us this number over here. That's going to give us 30 315ths divided by 1 over 1.5. That works out as a decimal is 0.14, and you can go ahead. I mean, obviously, we can use a calculator. That's what calculators are for, right? That's calculators. That's why, God created calculators is to allow us to do this. Works out to 0.14, and at least for now, unless I tell you otherwise, we can round this to hundredths. Because again, what we're really interested in here is not really the absolute number of it. Okay, what we're looking for is the relative value. Like, for example, what I said to you in our notes on elasticity, what we notice is as this demand curve goes up, okay, it gets progressively more elastic. That's because while I'll grant you $10 is generally a low percentage of income, unless you're an adjunct faculty member at Robert Morris. No, actually, that is true. As a result of that, it's going to be a higher percentage of your income regardless. Okay? So at some point in time, and this is kind of one of the general points that I made earlier, and I'm going to make again and kind of stress it, is that at some point in time, all products will become elastic. Because at some point in time, they're all going to become a large enough percentage of your income that it's going to matter to you whether or not there's a price increase. That the demand is going to become sensitive. You walk through another one here. As we go between these 2 points in the line, we have a difference of 30 units. We divide it by the midpoint. We have a difference in price of 1 unit. We divide it by the midpoint between 2 and 3, 2.5. That gives us 3285ths over 1 over 2.5. 0.26, and we do that again and again and again, and it's kind of painstaking. If you have a calculator, it doesn't take all that long. And you see that by the end of it, by $10, it really becomes quite elastic. Now, again, what I want to stress, again, what I've stressed before, we don't want to get ourselves lost in calculating these formulas and calculating the coefficients and the math behind it and lose sight of what the thing actually means. What do these numbers mean? This number here means that for every 1% change in price, there will be a 0.14% change in demand for the product. That makes it fairly insensitive, okay? Whereas up here, for every 1% change in price, there's going to be a 3.8% change in demand for the product, okay? This now is just to reiterate what I've been saying throughout. We look from the previous slide. We change from $2 to $3 using the midpoint formula. The resulting quantity change is from 300 to 270. That gives us this, which is 0.11, about an 11% change in quantity of demand. For the price change, 2 to 3, we use the midpoint, 2.5. That's about a 40% change in price. This results in an overall elasticity of 0.26. And what this means, once again, is that for every 1% change in price, you're going to have a 0.26% change in the quantity demanded. Now, let's graph this. Let's take a look at this. This is not surprising to us. This is something actually that we've seen before. If you remember from Lecture 3, I introduced that demand schedule. This is just an extension of that demand schedule. We figured out the equation of the line. We drew the line on a graph. We took a look at it. Doing the same thing here, only we have more points on the line. Okay, instead of it being, what was it originally, 2, 4, 6, 8, 10. Now we've got it going all the way up from $1 to $10. All right. And so go ahead, go back to that schedule, and you can just confirm this. For $1, we had this demand. I think it was 330 for $2. Our demand was 300 for $3. It was what we 270, etc., all the way up the line until finally for $10, demand was 60. This models the law of demand. As price is increasing over here, we have a drop in demand. Okay, and what we said was, and what we calculated from that extended demand schedule that I introduced a couple slides back, what we concluded was that, well, when we start out at a low price, and this is going to be true of all products, when we start out at a low price, the demand is fairly insensitive to the price increase. This is because it's a fairly low price. Okay? Well, so at all these points, demand was inelastic. Okay? Meaning it was insensitive. Once we got in this area, okay, this $6 area, the line started, demand started to become elastic. In other words, the quantity of demand started to become sensitive to a price change. Okay? And then for the remainder of the line, it's elastic. Okay? There's no coming back. So that's what it looks like. So at all these points, it's inelastic. At all these points, it's elastic. Now, let's look at the total revenue test, and let's work with this a little bit until we get it down. In general terms, okay, if the elasticity is less than 1, meaning that the demand is fairly insensitive to a price change, the percentage change in demand is going to be less than the percentage change in price, okay, then if we increase price, we're going to have a revenue increase. Now, you see here, it's very simple to calculate revenue. You can come up with it almost intuitively. Price times quantity. How much am I getting per unit? How many units am I selling? Price per quantity. I charge $7 for my fish sandwich. I sell 10 of them. That's $70 in revenue. Simple enough? Okay. So if we increase the price, it's going to increase revenue. If we decrease the price, we're going to decrease revenue, which means a positive correlation between price and revenue. And while we're busy trying to memorize that, let's think it through. Why? Okay. We know that for a price change, right, there's going to be a change in demand. We know that from the law of demand. The reason is because, let's say we raise price, okay, but demand is insensitive, relatively insensitive, less than 1. Relatively, the percentage change in demand is going to be less than the percentage change in price. Let's just think about that, okay? That's what it means if it's less than 1, okay? That means the increase in price per unit is going to more than compensate us for the reduction in demand per unit, okay? We're going to be getting more money in per unit. We're going to be selling fewer units. But if it's less than 1, the fact that we're getting more money in per unit is going to more than compensate us for the fact that we're selling fewer units. If it's greater than 1, exactly the opposite is true, okay? Price up, negative correlation between price and revenue. Now let's think that through for a second. What it means if it's greater than 1 is that quantity, demand, is fairly sensitive to a price change, which means that a price change, okay, whatever that may be, you're going to have a larger demand change. Okay, so if we increase price, granted, we're getting more money in per unit, but that's going to be more than neutralized by the fact that we're selling fewer units. Okay? The increase in our price per unit is going to be negated entirely, and then some, by the fact that we're selling fewer units. So this elasticity is of critical importance to us. Okay? It's going to be critically important to us as an entrepreneur. It's also going to be critically important to us as a government agency. Okay? Because this is going to determine rather, which products we tax, and in terms of their demand function, in terms of the price of the product, where and how much we tax them. Okay? Now, if the elasticity is 1, and exactly 1, then a price change will have no effect on revenue. Why? Because, well, let's think about it for just a minute here. Okay? If the coefficient is 1, what does that mean? That means that the percentage change in demand is exactly the same as the percentage change in price, which means if we're getting fewer dollars in per unit, we're going to compensate for that by selling exactly the same percentage more units, and so it's going to be equal. All right? And vice versa. And vice versa. Okay, and this is an example of this. We just talked about the total revenue test. What do we notice here? And we want to make an explanation as to why this is the case again, just kind of to reiterate the point. And this is the table that we've been working with. These are the elasticity coefficients, price elasticity coefficients that we calculated earlier. When we move from $4 to $6, okay, note what happens to our revenue. Revenue is price times quantity. So for $4, it's 240 times 4, $960. We move up to $6, 180 times 6, $1,080. Okay, so we increase revenue by $120. But when we increase it another $2 from $6 to $8, we actually reduce our revenue. This is going to be of critical importance. One of the things, and it is often counterintuitive. A lot of people think that, oh, to increase my revenue, to increase the money I make, I simply have to increase my price. That's not necessarily true. It depends on the elasticity of the product. It depends on how sensitive to a price change the demand for the product is. Okay? And we'll look at the end at what's going to determine that sensitivity, or what some of the determinants of that sensitivity are. For now, that's what we want to think about. Again, I'll reiterate the point. What do these numbers mean over here? This one, for example, means that for every 1% change in price, we're going to have a 1.6% change in demand. And that's why the total revenue test works the way it does. Okay? We're getting, with the price increase from $6 to $8, we're getting more money in per unit. But the reduction in demand is large enough, okay, as a percentage, that we're selling too many fewer units. We're getting more in per unit, but we're selling too many fewer units for that to increase our revenue. Now, this gives us the total revenue curve. And we want to just rest here and look at it for a minute and take a look at why it is the way it is. And we'll do this again in the next slide a little bit as well. Now, it's important, first of all, to remember what we're looking at here. Okay? What we have over here is the revenue, and what we have over here is the demand. So one of the things I want you to be able to do in your brain, in your mind, simply enough, is to kind of figure out where we are price-wise in the product. Well, we're going to be over here is going to be the lower prices, right? Because we have higher demand. As we move this way on this axis, we're increasing the price of our product. Okay? So as we move up this total revenue, we see our revenue maxes out right here. Okay? Which is at this demand, and if we remember from the demand schedule, that's at about $6. Okay? So as we have very low prices, $1, $2, $3, $4, okay? And I'm asking you to superimpose this in your brain. You don't really have to. You have the PowerPoints. Hopefully you have the PowerPoints printed out, or you can have them on a separate screen as you're looking at this and kind of confirm this. This is where demand is highest, so we have the lowest price. As we go up in price, now keep this in mind, okay, because we calculated this, we looked at this. As we go up in price and therefore down in demand, what's happening to our elasticity? Well, demand is becoming progressively more sensitive to a price change, which means what's happening? This is flattening out. Our revenue increase is becoming less and less and less each time, with each successive increase in price, until we reach this maximum point. Then, we still have prices are still rising, which means demand is still falling. And once you hit this figure right here, which is $6, I remember, once you get over that, the elasticity coefficient is actually greater than 1, which means demand is now relatively sensitive to a price change. Means the percentage change in demand is going to be greater than the percentage change in price. So while you're going to be getting more money in per unit, you're going to be selling too many fewer units to compensate. Okay, so it's going to negate that price increase per unit. We're going to drop down here, okay, with every successive price increase. All right, so somewhere in this area, the elasticity is going to be exactly 1. Okay, and if we were to really delve into the micro quantum level of this, which is a lot of fun, kind of painstaking, but a lot of fun. You get into the real quantum incremental changes. I mean, you could calculate if you were of a mind to, if you had sufficient time and energy and really wanted to, or if you correctly wrote the formula in Excel, it would do it for you. You could figure out what the elasticity is for every 1,000th of a penny change, okay? All the way going up here and find out exactly where that's 1. We do that in upper level economics. It's a calculus function, okay? But here we won't do that. But it's kind of fun. You could do it algebraically and kind of have fun with it. But you'd have to have either some sufficient time or have Excel do it for you. And I suspect that we're not going to do that. We want to just move on. And certainly in this lecture, we're going to just move on from there. Okay, now let's draw some extrapolations. Extrapolations are logical conclusions based on what's previously been said. Okay, and a lot of this we've talked about before. Here's our total revenue curve, which we just figured out in the last slide. Okay, it's exactly the same one. In fact, I just copied and pasted it. Okay, as price goes up, remember, as demand's dropping, price is going up. As price goes up, we move closer and closer to 1. Somewhere here we hit the number 1, right around where we hit our total revenue, our maximum revenue. Okay, so it's always going to be. It's always going to be one of these parabolic curves, and it's, right around our revenue maximum. That's where we're going to hit 1. Then at peak revenue, we converge at 1, and then as price continues to rise, it's going to move away from 1. It's going to get larger and larger and larger. I don't want you to get confused here. This over here on the vertical axis is not the elasticity coefficient. Okay, the elasticity coefficient is actually going to kind of look like this. It would actually look like this. It would go upwards, upwards, and upwards. But at any rate, so here we're at 1. Here we're moving away from 1. Here we're moving towards 1. All right. Now we talked about this already. What does it mean if the elasticity coefficient is 0? Well, it means then that quantity would be completely insensitive to a price change, meaning that there would be a price change and no quantity change at all. Well, we know from the law of demand that that's not going to happen. So it exists only at a abstract theoretical level, because it's not actually going to happen. But what about it being infinite? Could it be infinite? Well, the idea is that no, it can't be infinite. Okay, what does it mean for the elasticity coefficient to become a very, very large number? It means that you would have, for small incremental changes in price, massive changes in demand. And that's possible. You can have that. Absolutely, you can have that. But it can never be infinite. Because why would it be infinite? As it moves towards the limit of infinity, okay, it means that the change in quantity demanded is going to become enormous. Okay? Well, it can be enormous, but it can never be infinite. Why can it never be infinite? It can never be infinite because the quantity demanded can never be infinite. Why can the quantity demanded never be infinite? Because you have scarce resources. We're all the way back to the assumption on scarcity of resources. Demand can't be infinite because resources are scarce. One of the things that's always bothered me in economics is the way that one of the things they say defines economics is that wants always exceed resources. Okay, that's true, but wants are never unlimited. Unless you are kind of almost sociopathic, there is a limit to what you want. You guys you might want an awful lot. I might want a Mercedes-Benz and a 15,000 square foot mansion and a job that makes me $10 million a year. but I don't want infinity. Nobody does. There has to, it doesn't. The human mind doesn't function that way because, among other things, one of the things I found out when I was studying calculus, which is really kind of interesting. I just sat there tripping out for like 2 days on this idea. When I finally grasped the idea of infinity, it's beyond the human comprehension to comprehend infinity. That there is no beginning and no end. That it's never ending. Okay, so I can conjure really, really, really large numbers. But infinity itself is something that is just beyond my human mentality. Okay, that's why it can't be infinite. Okay, now one of the more interesting implications of this total revenue test and the relationship of revenue to the elasticity of demand for the product. Again, we have our standard fish sandwich demand curve, which I suspect by the end of the semester it's going to drive you crazy. You're either going to become obsessed with fish sandwiches and become fish sandwich addicts like I am, or you're never going to want to see one again as long as you live. But at any rate, okay, let's raise the price again from $4 to $6 as we did previously. Okay, but the government now is going to levy a 50% tax on food products. That is why the price increase is happening. So we're charging $4. The government levies a 50% tax on food products at local bars. Okay, this is not entirely out of the realm of possibility. In fact, in Pittsburgh, maybe 5 years ago or so, very controversial. They passed what they call a pouring tax. They passed a tax on alcohol. Every time you poured, that's why they called it a pouring taxes. Every time you poured alcohol, they taxed it. Okay. Well, we'll do that with food at our tavern. Okay. Now, what does that mean? Well, with the price increase from $4 to $6, note that revenue goes up from $960 to $1,080. Okay. The government is going to keep $2 of this for the tax, and the entrepreneur, the tavern master, is going to keep the other $720. Okay, they keep $2 a unit. We now sell 180 units. That's going to give the government $360 in tax revenue. Out of a total of 1,080, that'll leave the entrepreneur with 720. Okay, this becomes critically important for government taxation. We're going to talk a little bit later in the half semester about the microeconomics of government. Well, one of the things we're going to talk about is government taxation, particularly government taxation at the local level. Okay, because what we want to be able to do as the government is pass taxes to raise revenue. Okay, but we want to do so that we don't injure our entrepreneurs. We don't want them to lose revenue. Okay, now with the second thing, let's suppose now that we levy a tax of 33%, and I kind of did that to try to keep the math a little bit simple here, so that we're starting out at $6, okay, with a revenue of 1,080. They impose a tax of 33%, which is 1/3, which will raise the cost up to $8. Now let's take a look at what happens. With the price increase resulting from the tax, we actually have a revenue decrease down to $960, okay, of which the government is going to keep $2 per unit, okay. At $8, we'll sell 120 units. The government will keep $2 of that. The entrepreneur will keep $6 of that, okay. Well, what that means is that the government actually is only keeping 240. The entrepreneur does as well as he did last time, $720. So they're no worse off. But the government is better off to tax it at 50% from $4 to $6 rather than from $6 to $8. What does this ultimately mean? Well, what we can extrapolate from this is that it's better for the government to tax items that are lower in price, or at least that given a certain item, that governments want to tax it when it is at the lower price end of its demand curve. Okay? Because one of the things we know is at some point in time, all products are going to become elastic. Okay? Um, all right. Moving on to cross elasticity. Now, I mentioned to you that unlike price elasticity, with cross elasticity, and when we look at income elasticity, we are going to be concerned about the sign of the elasticity coefficient, which is to say, we're going to be concerned with whether it's greater than or less than zero. And there's a reason for that. The sign of that coefficient is going to tell us right off whether it is a complementary product or a substitute product. And we want to look at this a little bit and explain why it's going to tell us that. Okay? Now, what we know from related goods, let's just review what we know from related goods from the discussion, the introduction to demand. Okay? We have two types of related goods. We have complementary products and we have substitute products. Now, let's look at how they work. Okay? If there is a price change in a product, okay, for example, a price increase, it means that the demand for that product is going to drop. Well, if another product is a substitute, what we said was that the demand for the substitute product will go up. If a related product is a complement, the demand for the complement will go down. Okay, so if two products are substitutes, their quantities are going to go in opposite directions. If two products are complements, their quantities are going to go in the same direction. Okay, now as a result of this, what this means is if the cross elasticity, which is expressed as EXY right here, okay, if the cross elasticity is less than zero, they're complementary products. And if the cross elasticity is greater than zero, they're substitute products. And this is ultimately because we'll see this as we go through examples in the math, but ultimately it's because if it's complementary products, okay, a price increase will lead to a quantity decrease in the complement. A price decrease will lead to a quantity increase in the product. So you'll have price and quantity moving in opposite directions. And when you have price and quantity moving in opposite directions, it's going to become a negative number. You're going to have a positive in the numerator and a negative in the denominator, or vice versa. Exactly the opposite is true of substitutes. Okay, when it's a substitute product, price and quantity will be moving in the same direction. Okay, if there's a price increase in a given product so that its demand goes down, a substitute product for that will go up. So if Coke raises its price, the demand for Coke will go down, the demand for Pepsi will go up. And so price and quantity, the price of one product and the quantity of its substitute product, will be going in the same direction. Because of that, you're either going to have a negative number in the numerator and in the denominator, or a positive number in the numerator and the denominator. Okay? Now, the general form of it, of how we figure it out, is right here. We want you to remember that to solve the problem of whether we're going up or down the demand line on these products, we use the midpoint formula. Okay? We take the average of the price. Given a price change, we take the average of the two prices. Given a quantity change, we take the average of the two quantities. Now, let's look at complementary products. Let's suppose, now let's go back to our tavern. I know at this point in this lecture that would be a wonderful repast for most of us. We would desperately like to repose down to our local tavern. But at any rate, we go back to our tavern. And let's suppose that at our tavern, for every fourth fish sandwich that we sell, somebody drinks beer with it. Okay? Meaning that beer and the fish sandwich are complementary products. They're enhancing complements. Some people enjoy a good beer with their fish. I don't. I don't drink alcohol at all, but even when I did, I didn't. Okay? Because I like fish sandwiches. I really enjoy fish. Okay? And so when I eat fish, I want just the fish. I drink a glass of water, something that has no taste whatsoever, so that nothing interferes with the taste of that fish. That's why I don't put cocktail sauce or tartar sauce or any of that nonsense on it. Some people do. Some people find, for example, cocktail sauce or tartar sauce to be enhancing complements to a fish sandwich. I don't think anything enhances the quality and taste and texture of a really good fish sandwich. But at any rate, now I'm digressing. All right, but at any rate. Okay, so let's just suppose, okay, that for every fourth customer, uh, 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 for every fourth fish sandwich we sell a beer. All right? All right. Now, what does this mean for compliments? Well, exactly what I said in the last slide. If the price of our fish sandwich goes up, the quantity demanded for our fish sandwich is going to go down. That's consistent with the law of demand and everything that we've said so far. Well, what it also means is if beer is a complement for that, it means the demand for beer is going to go down. Okay? We know exactly how much based on that stipulation that I meant. Okay? For every fourth fish sandwich we lose in sales as a result of the price increase, we're going to lose one beer. Okay? Now, components and enhancers, and just kind of think this through so that we're all on the same page. You're going to have a larger absolute value of that cross-elasticity coefficient if it's a component. Okay? The more related the goods are, the larger that number is going to be. Why? Well, let's think about it again. Let's think about what that number means. What this number means is the sensitivity of demand for one product based on the price increase of another product. Well, if they're really, really closely related, such as computers and microchips, or the example I used, 5 minutes ago, Coke and high fructose corn syrup, which is the sweetener used in Coke, okay, they're completely related. They're lockstep with each other. You can't have Coke without high fructose corn syrup. So if demand for Coke changes, it's going to be a lockstep change in the demand for high fructose corn syrup. So the more related they are, the larger that number is going to be. And that's why components like high fructose corn syrup in Coke, okay, or like microchips in computers, or like pistons in automobiles, or gasoline in automobiles, is going to be a much larger relationship. It's going to be much more sensitive than two things that just enhance each other, that you can get by without them. Okay, maybe you like your pie and your ice cream, but, if they jack up the price of ice cream too much, I'll eat my pie alone. Okay, whatever. All right. Okay, we'll now work through an example of this cross elasticity, and we'll use complementary product here. What we've just said is that 1 out of every 4 of our fish sandwich customers like to have themselves a nice brouhaha while they eat their fish. Okay, so for every 4th fish sandwich we sell, we're going to sell a beer. That's how we're going to derive this demand schedule for beer. Okay, is quantity demanded for the fish divided by 4. Okay, and we'll round to the lower whole number. I'll always explain to you how the rounding goes so that you won't have to intuit it, but you probably can intuit it. We're not going to sell part of a beer any more than we're going to sell part of a sandwich. You either buy the whole thing or you don't buy any at all. And we're assuming that our consumers are rational actors, and so they won't waste anything. And so if they want, for example, 0.8 sandwiches or 0.6 beers, they're not going to buy it because they don't want to waste it if they're not going to take a whole one. So, the number 1.6 would actually be 1. We're not going to waste the other 0.6 because that would be an expenditure of resources that we're ultimately not going to use. And that's inefficient, and that contradicts the assumption of rationality. At any rate, a lengthy explanation for a simple point, I suppose. Well, let's suppose we change the price of our fish from $8 to $6. Again, it doesn't matter which way we go, from 8 to 6 or from 6 to 8. We look first now for the percentage change in the quantity of the complementary product. Again, we're using the midpoint here, so we have a difference. We're gonna change from 30 to 45 in terms of the demand, the number of beers we're going to sell with our fish. That's going to be 45 minus 30. That's going to be 15. Now remember here, we are interested. We're not using absolute value. When it comes to cross elasticity, we're not using absolute value. So it is going to matter to us which way we're going, up or down the demand curve. we're going to continue to use the midpoint so that whether we're moving up or down, it's going to be the same percentage change. Okay, that's 1537 and a halves. Okay, it's a positive number, you see. The price will be a negative number, won't it? Because we're moving from 6 to 8. Now, note what would happen. Okay, note what happens in terms of the sign. This is what we said. I told you that complements, okay, complementary products are going to have a cross elasticity that's less than 0. Why? Well, because look, right here we're changing price of fish from $6 to $8. Okay, so the price is going to be a negative number, 6 minus 8 divided by the midpoint. Okay, the quantity is going to be a positive number because we're going down in quantity from the first number of 45 down to 30. If we reversed that, we would go from 30 to 45 and have 30 minus 45 up here. Again, divided by 37.5. Okay? Hence, the cross elasticity here is going to be negative 1.4. Okay? And again, we'll get our calculators to do this for us. Now, the cross elasticity of substitute products. Suppose that within a radius of 5 miles, there are 6 other taverns, all of whom have fish sandwiches. In point of fact, at the last of the restaurants that I worked at, which was a bar restaurant, within a 3-mile radius, there were 6 other taverns, okay, all of whom served fish sandwiches. So that's a highly competitive market, okay? From our previous discussion in Lecture 3, and from what we discussed just earlier here, if we raise the price of our sandwich, demand for our sandwich will drop, and demand for our competitors' fish sandwiches will go up. Why? Because if we raise the price of our fish sandwich, they'll run next door and buy the other guy's fish. Okay? All right. So now here we have the basic relationship. If the price of fish for us, our fish, okay, goes up, the quantity demanded for our fish, us, goes down, and the quantity demanded for their fish, them, goes up. Okay? Now, again, we'll make a reference to this. The cross elasticity will be greater the less the degree of product differentiation. Product differentiation refers to the ability to differentiate between 2 products. Okay? So if our fish sandwich is effectively the same as theirs, okay, the cross elasticity is going to be much larger. Okay? If there's product differentiation in terms of quality, okay, if people like our fish better because it's better, then we can increase the price of it. Our demand won't go down. They won't go to our competitor because we have a little better price change. Okay? We'll deal with that a little bit more when we get to the discussion of markets and imperfect markets and the idea of product differentiation, which is ultimately a monopolistically competitive market. And that's most taverns, most restaurants are in monopolistic competition. We'll deal with that later on in the semester. But at any rate, for now, we just worry about product differentiation, okay? If the 2 products are identical, such as coal or corn, okay, a price increase in one will lead to a demand decrease in it, which we know from the law of demand, but all of the people that were demanding that corn will go and buy somebody else's because there's no difference between the 2, all right? Okay, this is why, well, you know what? We'll hold that off until we deal with competition specifically. Let's take a look at an example now of a substitute product. And what did we say? We said that with substitute products, the cross elasticity is going to be a negative number. It's going to be less than 0. Okay. Now, what we've been setting up, what we just set up in the last slide, was the idea that okay, we're in a relatively competitive market. Okay, we have a lot of taverns around us, all of whom are selling these fish sandwiches. All right. So when we raise the price of our fish from $6 to $8. Okay, we'll sell 60 fewer units. Let's suppose that as a result of this price increase, half of our customers, okay, will go elsewhere. The other half of the 60 is just going to give up their fish sandwich habit. Okay, we'll just assume that. But what this means is that our competitor, who faces the exact same demand schedule, okay, we're going to assume that our competitor, their demand schedule is exactly the same as ours. Well, what that means is if they're selling theirs for $6, their demand is going to go up from 180 to 210 units. Okay, half our customers go over to them. Well, now we just figure out the cross elasticity. And again, it's going to be a substitute product. Again, we use the midpoint. But now let's notice, okay, here's the quantity demanded of fish for them, they, the enemy, the opponent, the competitor, okay, 180 minus 210. They go up in numbers, so we're going to have, this will be a negative number. We'll end up with negative 30 over 195, okay. For our fish, our price, we're going from $6 to $8. Well, that'll be a negative number. 6 minus 8 is negative 2. We'll divide that by the midpoint of 7, okay? And so hence, we'll end up with an overall cross elasticity of 0.54. Now, what does this mean? Well, again, we want to stress this. I want to stress this over and over. We want to drum this through our head. What this means is that for a 1% change in the demand for my product, there will be a 0.54% increase in the demand for another product. So a price change of 1% is going to create a quantity demand change of 0.54% in my competitor's product, in a substitute product. Okay? Simple enough explanation? Good. Now, on to income elasticity. We know from our discussion in Lecture 3 that if we change income, we're going to shift the demand curve. We're going to change the amount of demand. The question, of course, that doesn't answer, we're going to answer now is, okay, for a given change in income, for a percentage change in income, okay, for whatever we change income, how much of a change in demand is there going to be? How much is it going to shift that demand line? How much is it going to shift that demand curve? Okay, and here we use I to symbolize income. Okay, E is going to symbolize elasticity. So this is what we're talking about with income elasticity. So we have the percentage change in the product, the percentage change in the commodity, based on the percentage change in income. Okay, now generally, there are a few general statements that we can make. Okay, the two really. The income elasticity tends to be more for durable goods than for non-durable goods. We introduced the difference, of durable goods that can be used multiple times in their intended use, as opposed to consumable goods which can only be used one time in their intended use. Okay, we introduced that a few lectures back. I think when we were introducing demand, or maybe even before, when those preliminaries, whenever. Okay, we introduced that idea. So I just want to bring that back to your memory. All right. Well, durable goods tend to have a higher income elasticity than do consumable goods. Okay, why is this? Well, just because I make more money doesn't mean I'm going to eat more. Okay, if this were not the case, if it was the same, if consumable goods had a high income elasticity, then the more money I make, the more consumable goods I would take on, I would use. Okay, now if that were the case, then Bill Gates would be the size of a small planet, wouldn't he? Okay, because he'd just be consuming consumable goods constantly. Okay, well, in point of fact, that's not the case. It is the case that he has Lear jets and mansions and all that stuff that the rich folks have. Okay, that we normal folks don't have. Okay, well, that's because it is very sensitive. Durable goods, the demand for durable goods is much more sensitive to income elasticity. The more money you make, the more durable goods you're going to have. Okay, simple enough to understand. Also, the income elasticity is greater for luxury items than it is for necessities. Okay, so if my income goes up and down, I still need to eat. Okay, there's nothing I can do about that. It's going to be fairly insensitive. But if my income drops, I can do without luxury items. If my income goes up, then I can afford some luxury items. And we'll define what we mean by luxury items, because there's a problem there. And maybe you've already jumped to it in your mind, but there's a problem with the definition of luxury items in general. Now, the other thing, let's look at this. Okay, kind of similar to what we were dealing with cross elasticity. Once again, when we deal with income elasticity, we're going to be concerned with the sign of the coefficient, whether it's greater or less than 0. Normal goods will have a positive coefficient. Okay, and we'll go through why they do. We'll look at normal goods and go through why they do. Just quickly, what do we know about normal goods? Well, by definition, a normal good is a good in which when my income goes up, my demand for that good will go up. And when my income goes down, my demand for that good is going to go down. Because they're going in the same direction, okay, it's going to have a positive coefficient. This is similar to what we saw with substitute products, because the price of one product and the demand for the related product, the substitute product, are going in the same direction. Remember, with substitute products, we said if the price of one product goes up, the demand for that product will go down, and the demand for its substitute will go up. So the price of one product and the demand for the substitute product are going in the same direction. Okay? Because of that, what you're going to end up with is a negative in the numerator, a negative in the denominator, and therefore an overall positive expression for the coefficient. Same thing here with normal goods. Inferior goods, exactly the opposite. They're going to be more similar to complementary goods. Okay? So what you're going to have, and remember, I'm not saying that they're the same thing. I'm saying that they're more similar in terms of how you're going to calculate the elasticity. Okay, so for an inferior good by definition is if my income goes up, my demand for an inferior good will drop. And if my income drops, my demand for inferior goods will go up. Okay, so as a result of that, okay, if my income drops, I'm going to end up with a positive number for the percentage change in income. And my demand's going to go up. Because they're going in opposite directions, you're going to have a positive in either the numerator or denominator, and a negative in the other one, in either the numerator or the denominator. So you're going to end up with a negative overall coefficient. Okay? And that's more for the math geeks in the crowd that like thinking about that kind of thing. Okay, now let's look at an example of income elasticity. And here we're given, let's suppose that our sandwich, our product, has an income elasticity of 0.75. And a couple of things to note here just at the onset of this. First of all, remember when in Lecture 3, when we talked about income as a shifter of the demand curve, we didn't talk at all about overall value, the actual value of income. Okay, we're not interested in that. We're interested in changes in income. What we said was that as income goes up, which means a positive change in income, demand for normal goods will go up, the demand curve will shift outward. If we have an income decrease meaning a negative change in income, for normal goods, the demand curve will slide inward. We'll have a reduction in demand, okay? So we're only interested really in the percentage changes, and really all along in our discussion of elasticity, that's what we've been looking at. We're not interested in the actual numbers. We're just interested in the percentage changes. Okay, we figured those out by using the actual numbers, but here we're just given it. Okay, so we're given an income elasticity of 0.75. Now, the second thing we want to point out here is let's just take a look at that coefficient. What do we know right now going in? Okay, well, we know that income elasticity coefficient is greater than 0. It's 0.75. What does that mean? Well, that means we have a normal product. Why do we have a normal product? Because the income change and the demand change are going to be going in the same direction. Income down, income up, demand up. That means by definition it's a normal good. If it were an inferior good, that coefficient would be negative, because income up, demand down, income down, demand up. So we know just going in, just by looking at that number, that it's a normal good. We need to go no further for that. Okay? Now let's suppose that our customers receive some bad news that from the township or from whomever, that their property tax is going to go up by 5%. Okay? Now what does this mean? Well, whenever you increase taxes, you reduce disposable income. Okay? If I've got money coming in, let's say I've got $100 coming in, without any taxes, that $100 is mine to spend as I see fit. But if you tax it by 5%, then $5 of that 100 has to go to the government, and my disposable income is reduced down to $95. It's a 5% reduction in my disposable income. All right, simple enough? Okay. So this means a reduction in the disposable income of 5%. So we're going to have a negative change in income. We're going to have a reduction in income. Okay, so that's going to be modeled down here. That's going to be included down here as -5. That's our change in income. Now, we're just going to use just a little bit of basic algebra to figure this out. We're given our elasticity coefficient. Well, what did we see? What have we learned all along about how elasticity coefficients are arrived at, okay, are calculated? The elasticity coefficient equals the percentage change in quantity divided by the percentage change in here income. Before it was price. With cross elasticity, we had the cross elasticity coefficient was the percentage change in quantity demanded of one product by a percentage change in price of another product. Okay, well here, independent variable, dependent variable, if you want to think of it that way. 0.75 is the percentage change in the demand based on a percentage change in income. Here we're given that it's a -5% change in income. Okay, we just have to run this now through and do a little bit of algebra. We bring the -5 over here. That gives us -3.75% is the changed quantity. Whenever you see this, I don't know if I've explained this yet or if you're familiar with this. Whenever you see this symbol, this is the Greek symbol delta. Delta kind of universally is used to refer to change. And I think I've used that throughout. I don't know that I've explained it. But delta always refers to change in. So the percentage change in quantity. So the percentage change in quantity here is -3.75%. Now notice that we're not getting the actual number. We're not getting the actual number that changes. What's going to be the new demand for our fish sandwich? Notice we also haven't referenced anything to do with price of our sandwich. Okay, we haven't referenced the price of our product at all because it's inconsequential. Okay, what this means is that across the board, throughout that entire extended demand schedule, all throughout, we're going to lose 3.75% of demand for our sandwiches because of this income reduction. Okay, we could then go through and figure out what the new demand is going to be at every single price level by reducing it by 3.75%. I'm going to introduce a problem in a little while where we're going to do something like that. Now, let's work on the determinants. And I've mentioned this a little bit, okay, in terms of like related products that enhancers are less have less of an impact on the demand than do components, etc. Excuse me. Let's go through them specifically now. Let's first look at necessity versus luxury. Now, here we run into a problem right away in terms of the definition of necessity and luxury. We generally try to define it as objectively as possible. So a necessity is a very fungible product. But that's not entirely true. Okay? And this is where we get into a problem. We're going to see this problem again in the next lecture, actually, when we deal with utility. The problem is in defining the distinction between a necessity and a luxury. I'll give you an example. Okay, I'll give you an example. A little while back down on the yellow brick road, okay, my wife announced to me that she needed was the word, indicating a necessity, needed to have her nails done. Now, needed? Really? That not a luxury item? Having your nails manicured is a necessity? It's not a luxury? Okay, whatever. Okay? To me, the way I would think of needed is it's necessary to sustain life. Okay? Like, for example, I mentioned to you in a previous lecture that they just finished actually yesterday. We just had our basement waterproofed. Well, we needed to have it waterproofed. It was a necessity. Why was it a necessity? Because of the humidity level down there, mold was beginning to grow, and that mold had invaded the upper level. Okay? If that mold becomes pervasive enough, it will kill you. Okay? It will choke off your lungs and kill you. So that needs to be done. Nails, you know what? My nails could become in deplorable conditions. I'm still going to survive. So we discussed that a little bit. A little bit you discussed that, right? But at any rate, that gives an example. And so it's very subjective. It's a very subjective viewpoint. Now, by the same token, okay, you know, not to sell my wife short, who I don't want to sell. You know, I view Breyer's ice cream as a necessity. Some people wouldn't. Some people would say Breyer's ice cream is a luxury item. Not me. It's a necessity. I have to have it. It sustains my life. Without it, I don't know what life would be like. For a lot of people, bacon is a necessity. Okay? But at any rate, all right. So this is our problem. Now, generally speaking, okay, items that are necessities have a much lower elasticity, meaning they're much less sensitive. The demand for a necessity is much less sensitive to price changes or income changes, okay, than is a non-necessity, okay? And so down here, gasoline, addictive substances, those are pretty much considered necessities, okay? And so a price change is going to be very insensitive. This is why, if you remember, we talked briefly about the tax implications of our discussion of elasticity. This is why the two most frequently taxed things by the state are gasoline and cigarettes. Gasoline is a necessity, okay? Cigarettes are an addictive substance. Hit the addicts. Hit the addicts is who you want to hit, okay? Because a price change is not going to change the demand that much. Now, we know this. That's true. That's true. But we know this. We know from our previous discussion that at some point, eventually, all products become elastic. Okay? As you start out at low prices with high demand, the product is inelastic. As we go up that demand curve, okay, with increasing prices and reduced demand, the elasticity is going to get higher. At some point, it becomes elastic. We notice that, like, for example, they've played this game for the last 5 years, at least 10 years, with gas prices. Okay, they start off at whatever number, $3, and they ratchet that price up, okay, as far as they can, and then all of a sudden it starts dropping back down again. Okay, that's because at a certain point, even gasoline becomes elastic. Right now, it would appear that that's right around in this area, in the greater Pittsburgh area in West Pennsylvania. It seems like that's right around $4. Once they move it in the direction of $4, $4.05, they start to ratchet it back down again. Okay, because what they notice is that demand is starting to drop for it. Okay, prior to that level, they really don't notice it that much. Okay, it works the same way in reverse, by the way. What we've witnessed over the last year or so is this tumbling of gas prices. I think at one point it went to a low of like 205 I saw someplace, okay? Well, I don't know about you, but I didn't drive anymore when the gas price went down. My driving habits stayed just about the same. It's not like I all of a sudden decided, okay, I'll go out for a pleasure drive now, go drive around in the country. I pretty much drove to school, drove to the store, drove over to my in-laws, drove, whatever. Okay, it stayed pretty much the same. So it's this insensitivity. Now, I suppose at a certain point the same thing is true, that at really, 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 really low prices it'll become elastic again, meaning that at a really, really low price I would, like if they gave me gas, I would probably go out on pleasure cruises and drive a lot more. I would love for them to experiment with that, just a little bit anyways. But at any rate, so we get the idea here that while it's true that these necessary items are less elastic, less sensitive to a change in price or a change in income, at some point in time, everything becomes sensitive. Okay? Second thing, related goods, and we've talked about this before, substitute products. The greater the availability of substitutes, the higher the elasticity. Okay? Meaning, the more substitute products there are out there, each of them is going to have a greater sensitivity of demand to a change in price or to a change in price of their substitutes. Okay, so if we have a marketplace like the one I used in the example earlier, when we had, half a dozen bar restaurants within a 5-mile radius of us, that means there's a lot of substitutes. Okay, we're going to have a higher sensitivity. Okay, whereas if I'm the only bar restaurant in town, there's going to be a much lower sensitivity. There's much fewer substitute products. Okay, so I'm going to have a much lower sensitivity to price changes, income changes, etc. Okay, same thing with kind of complementary products. The more strongly related the complements are, the more lockstep the elasticity is going to be. Okay, in other words, if two products are very highly related, such as in components, the percentage change in quantity of the one product will be almost matched exactly by the percentage change in quantity of the other product. Okay? Percentage of income, and this actually explains why it is that as you go up the demand curve, meaning lower quantities, higher price, as you go up that demand curve, it eventually becomes elastic. The higher, generally speaking, the higher the percentage of income, the more elastic the product. The higher the percentage of income, the greater the sensitivity for demand for that product is going to be. Give you a quick example. Okay, let's look at the relationship of two products. Okay, automobiles and candy bars. Okay, automobile, entry-level automobile goes for $24,000. Okay, candy bar goes for $1.50. Okay, well, a 10% change in that automobile is going to be a higher percentage of my income. If they increase the price of that automobile by 10%, that's $2,200. Okay, the demand for that is going to be much more sensitive. It's going to be much more of a change in demand because it's a much higher percentage of income across the board. It doesn't matter how much income you make. It's a higher percentage of income than if they increase the candy bar by 10%. Okay, $1.50 candy bar, if they raise the price of it by 10%, 15 cents, so it's $1.65, demand's not going to change that much for the candy bar. Okay, so the lower prices are a lower percentage of income, and so they're going to be a little less sensitive to price changes. Again, at some point they're going to become sensitive. At some point, they're going to become, all things become sensitive at some point in their price structure. Okay, what happens is with durable goods, that tends to be at a lower price that they'll become sensitive. With higher price items, higher price ticket items, that's going to be at a higher price range. Okay, so the greater the percentage of income, the more elastic it's going to be. Okay. Now, just a kind of a final note on the general, and then we'll go work out a problem on this. But generally speaking, think about it this way: you have general and specific. Okay, and you have various levels of general and specific. I'll give you an example. Food as a general category. Now, as it works out, general categories of general categories of things tend to be less sensitive. They tend to have a lower elasticity. Okay, across the board. The more general the category, the lower its sensitivity. And so, a general category like food. You need food. Without food, you can't live. So if they raise the price of food across the board, all food at once rises across the board, you're not going to buy any less because you have to survive. Okay? Whereas the specific, where you get into specifics, they can tend then to be, they'll tend to be much more sensitive to price changes. Okay? And so, for example, while it's true that food as a general category is very insensitive to a price change, within that general category, you have additional kind of sub-general categories. Okay, where you have, ice cream, and you have beef, and you have bacon, and you have, cereal, and, bananas, and a whole host of other things. All right. Well, now within those sub-general categories, the sensitivity starts to go up a little bit. If they raise the price of beef too much, I'll eat fish. If they raise the price of cereal, I'll eat bananas. Okay, you see what I'm saying? Now, at its further extending, we can go into the very specific categories. Okay, and this is really where we're getting into substitute products. So if Oscar Mayer bacon goes up in price, I'll still buy bacon, but I'll buy Sugardale. And if Sugardale raises their price, I'll buy the generic stuff. Okay, whatever. Okay, I generally don't buy generic bacon. There are certain things I've learned that you don't buy generic, and bacon's one of them. Dishwashing liquid's another one. But at any rate, you get the idea. With cereal, okay, if Cheerios changes its price, raises its price, I'll just go eat cornflakes. If cornflakes raises its price, I'll eat Rice Krispies. If Rice Krispies raises its price, okay, you got a lot of substitutes within that. Okay, so the more substitutes there are, so that's why general and specific is the way it is. Okay, now let's work out a problem. Let's go. Let's go on to our problem. All right. I always like to end these things whenever possible with a problem. Now, looking at all the discussion that's come so far, we're not interested at all at this stage in the actual number. We're interested in percentage changes. We're interested in how much something's going to change. Okay? Now, we have a few things that we've talked about in this lecture and in lecture 3 that are going to change the demand for a product. In this case, we'll continue our example of the fish sandwiches. Okay? Let us suppose that we calculate the various cross elasticities and income elasticities. Okay? And so let's suppose we come up with Y and Z are going to be two related products to our fish sandwich. The one has a cross elasticity coefficient of plus 0.8. The other a cross elasticity coefficient of negative 1.5. Okay? Now, first of all, just rest for a minute here. We should be able to tell just from that, without any reference to anything else, what types of related goods these are. Okay? And we'll deal with that. I just want to see if you can do it off the top of your head right now. But we'll deal with that in a minute. And then we have an income elasticity of 1.2. Okay, so percentage change in PY is the percentage change in price of related good Y. Change in PZ is percentage change in price of related good Z. Change in I is percentage change in income. We've dealt with all this before. We've looked at all this before. Now we're just setting this up. So this is going to modify demand for our product. This is going to modify demand, in this case, for our fish sandwich. This will modify the demand for a product. Okay? Now let's interpret this. Let's not get lost in the formula. I don't want to get too lost in the equation and the solution and all that good stuff. We want to first of all think about what this means. What this means is that there will be a 0.8% change in demand for every 1% change in the price of related good Y. It means there will be a negative 1.5% change in demand for every 1% change in the price of related good Z. It means that there will be a 1.2% change in demand for every 1% change in income. Remember, we went through that. That's the interpretation of this elasticity coefficient. It's the percentage change in demand based on a 1% change in one of the other variables, in price of related good Y, price of related good Z, price of income here. Okay? All right. So far, so good? All right. Now, let's suppose that the following things take place. The price of Y decreases by 10%. The price of Z increases by 5%. And the community reduces property taxes by 5%. Now, I italicize reduces. I italicize which direction these changes are going on. And the reason that I point out reduces property taxes, if you remember in the previous example, we increased property tax. If you increase property tax, it reduces disposable income. Therefore, if you reduce property tax, it's going to increase disposable income. So that's going to be an income increase. Okay? How much will the change in demand for our fish sandwiches be at $7? Okay? We need to figure out the percentage change in demand based on the changes indicated above. Now let's go in. All right. First, the change resulting from the change in the price of Y. Okay? Well, the change in the price of Y is negative 10%. We multiply that by the cross-elasticity coefficient of 0.8, and we get a negative 0.8% change in the demand for our product. Now, this should be an indication of how these two products are related and why it works this way. Okay? Negative 10% change in demand for the related good means that demand for the related good is going to go up. The demand for our product will go down. So I would conclude from this that Y is a substitute good. What this means is we're dealing with this fish sandwich. It means that one of my pain-in-the-ass competitors probably dropped the price of their sandwich by 10%. Okay? Second, the change resulting from the change in the price of Z. Negative 1.5. That's what we're given as the coefficient. And what were we told last time? We told that the price of Z increased by 5%. That means that it's going to change demand for our product by negative 7.5. Okay? Now that should tell us something. Wait a minute. Yeah. No, that should tell us something. That should tell us something. Okay? What should that tell us? Well, look at the coefficient. There's a 5% increase in the price of the related good, which means that demand for the related good is going to go down. Okay? Demand for our good is going to go down too. That means that Z, my hypothesis would be that Z has to be a complementary product. Okay? Think it through. All right. Probably in this case, could be a number of things that are complementary products. 1.5 is relatively high. Maybe it's a component to our fish sandwich. Maybe the cost of bread went up, and so it's costing me more to make breadcrumbs. Maybe the price of codfish went up by 5%. Who knows? Okay. Third, the change resulting from the change in income resulting from the tax. Since it's a tax reduction, it increases disposable income. I mentioned that previously. Okay, and we have 1.2. That means that before, remember, it was a increase in the income tax or an increase in the property tax, and so it was a reduction in income. So we had negative 5. Well, this time it's an increase in income, so we have positive 5. So that will increase demand by 6%. That means that my product is actually fairly sensitive to income changes, which makes a certain amount of sense, but it's fairly sensitive to income changes, so 6%. Collectively, then, what do we have? The change in the price of product Y, related good Y, is going to lead to a negative 0.8% change in demand. The change in price of related good Z is going to lead to a negative 7.5% change in demand, and the change in income is going to lead to some good news on this count, is going to lead to a 6% increase in demand. We just add those three things together. Combined, that's a negative 2.3% change in demand. Okay, this will be negative 8.3, and then we'll have plus 6, and using the additive condition of math, it's negative 2.3. Okay. Therefore, the combined result of these changes will lead to a 2.3% decrease in demand for my product. Notice again, we're not at this stage, we will later on, we're not looking at the actual value. We're not looking at actually how many sandwiches I'm going to sell. Okay? We just know that this means a 2.3% decrease in demand for my product. Now, all right, now let's figure out in actual numbers what that means in terms of my sales. Okay, what that means in terms of the actual demand for my product. Okay, we're dealing with the price of $7. Okay, now what we looked at from the extended demand schedule and function, all that other stuff we've been looking at throughout this lecture, for $7, the demand was 150 units. All right, now this is fairly simple to figure out. You just have to think it through to figure out how to do it. You don't have to worry about mathematical formulas that much. Just think it through. We started with 150. We reduced that by 2.3%, which is 2.3% of 150. That's 0.023. That's 2.3% of 150. Well, 2.3% of 150 is 3.45. So demand for our sandwiches is going to drop by 3.45, which means demand will be 146.55. Now let's think this through. Okay, we don't sell, I mean, we could, but we don't sell 0.55 of a fish sandwich. You either buy the whole bloody thing, all 8 ounces of the fish, or you don't buy any. And so we're going to have to round this down. Okay, so we can't sell part of a sandwich, so we're actually going to sell 146 of them. All right? What effect will this have on our revenue? How is our revenue? That's what I really want to know, is how does this affect money in my pocket? Well, what's revenue? Revenue is price times quantity, right? Okay, well, price times quantity. $7 a sandwich, 146 sandwiches sold, 1,022 bucks. All right? Currently, the revenue at this level is 1,050, 150 units at $7, so we lose $28 in revenue. All right? And then this we've already solved. Our y and z complements are substitutes. Since y has a positive elasticity, cross-elasticity coefficient, it must be a substitute. Since z has a negative cross-elasticity coefficient, it must be a complement. Our fish sandwich, and we already discussed the thinking behind this as we went through it. Are our fish sandwiches a normal good or an inferior good? We have a positive income elasticity, meaning increases in income, increases in demand. That's consistent with a normal good, so our fish sandwich is a normal. Now, here's another application of the problem, okay? And again, this requires you to think it through. It's not terribly deep thought, but it's, kind of interesting. Let's assume that our fish sandwich is a half a pound, that we need a half a pound of codfish, okay? Given what we just determined that there's going to be 4 fewer sandwiches demanded because of the changes that took place. The changes in the prices of the two related goods, the changes in income, all these things, all these balls in motion led to a 2.3% reduction in demand, which worked out to be 4 sandwiches, which means we need 4 less sandwiches. Okay, what doesn't that mean? We need 2 pounds less fish. Okay, 4 sandwiches, that would be 2 pounds of fish because we've dropped our demand by 4 sandwiches. We need 2 pounds less of fish, right? Simple enough. Now the question is this, and this is kind of big casino. This is the $64,000 question. I'm sitting there in my restaurant in the back room watching all this take place. And I'm looking at the bottom line. I figured this out. I studied economics. I studied microeconomics at Robert Morris. Okay, so I know all this. I'm sitting back there with this calculation that I've done, and I've concluded that that demand for my fish is going to drop by 2.3%. Question is this: can I adjust for this? Can I neutralize this drop? Can I neutralize this reduction in revenue by increasing the price of my sandwich? Now, intuition, and to the layman, sure, okay. Because of all this, I don't really give a damn about how many of my fish sandwiches are being demanded, except insofar as it relates to how much money I'm bringing in. The bottom line is how much money am I bringing in, okay? I really don't give a damn how many I'm selling, okay? And so it makes sense, right? I want to increase my revenue, so I'll increase my price. That might seem reasonable. The answer is no. In fact, it will have exactly the opposite effect. Now, let's see why. Let's just read through this and see why. Okay? The elasticity from $6 to $7 was 1.0, which means that any price greater than $7, right now I'm charging $7. Any price greater than $7 will have a price elasticity coefficient of greater than 1. Right? We know this. Why do we know this? Because we looked at that demand line, didn't we? We looked at the demand schedule. We figured it all out. We looked at the demand line and we said, oh, wait a minute. Okay, demand becomes progressively elastic as we go up in price. Once it starts going, it gradually becomes that way. It's not going to suddenly drop back down. Okay? It becomes progressively elastic. At $7, from $6 to $7, the elasticity was 1.0. That means any price over $7, $7 to $8, the elasticity is going to be greater than 1. It has to be. Okay, this is a logical conclusion. And if it's greater than 1, what that means is that the change in quantity is going to be greater than the change in price. So if I increase my price to make more per sandwich, the result is going to be a reduction in demand that's going to be greater than that increase in price. So while I'll get more per sandwich, I'm going to sell too many fewer sandwiches to adjust for that change in demand. And as a result, my revenue is actually going to go down. It's actually going to worsen the problem. somewhat counterintuitively, what I'll need to do to neutralize that is actually drop the price of my sandwich. And we could figure out exactly how much I need because what I need to do is I need to create a 2.3% increase in demand for my fish sandwiches. Well, how much do I have to reduce price to get that? Okay, I need to sell. You know what? We figured it out. We figured out stuff like this in the preceding lecture. Okay, in both the preceding lectures for supply and demand. What did we figure out there? What were the questions? The questions I was asking were things like, oh well, how much would we have to change price to increase demand by some odd number of units? Well, we need to increase demand by about 4 units. Well, how would we do that? We could figure out the linear demand for our fish and figure it out that way. Okay, so there's lots of fun that can be had in these problems. But I think that concludes the lecture on elasticity. It was a long one, but elasticity is a concept that is of critical importance. In the next lecture, we will deal with utility maximization.